In a world gasping under the weight of its own progress, where smokestacks pierce the sky and invisible clouds of carbon linger like ghosts of industry, a new hope rises, not from the heavens, but from the ingenuity of those determined to heal the earth. This is not just another green tech project. This is a rebellion against the invisible enemy choking our future. Introducing CO2 Buster, an innovation born at the intersection of science and survival. This groundbreaking technology doesn't just measure carbon emissions, it hunts them. Precision filtration systems and cutting-edge materials, CO2 Buster captures and neutralizes harmful carbon dioxide from our atmosphere, transforming polluted air into a breath of possibility. Imagine cities where the skyline isn't blurred by smog, where each breath feels cleaner than the last, where innovation doesn't just drive progress, it saves it.
So moving to the prototype, the CO2 Buster is an innovative device that tackles carbon dioxide pollution by turning into a useful solid. It works by drawing in carbon dioxide gas, often from industrial sources. Inside a special compartment, this gas meets calcium hydroxide. These two substances then react together in a simple chemical process. The amazing part is that this reaction transforms the harmful gas carbon dioxide and the calcium hydroxide into calcium carbonate, which is essentially like chalk or limestone. So instead of releasing harmful gases into the atmosphere, the CO2 Buster produces a stable, harmless and even valuable material that can be used in construction or agriculture. The fan appeared to be mounted on the side wall of the transparent enclosure. Here's a basic explanation of how gas such as air is inhaled through the fan. First, fan orientation. The blades of the fan are oriented in a way to pull air from outside the box and push it inside, assuming it's set as an intake fan. The direction of airflow depends on blade curvature and motor direction. Second, suction effect. When the fan spins, it creates a low pressure region on the intake side. This pressure difference causes gas from outside the enclosure to be sucked into the box. And last, airflow path. The gas flows through the fan blades and it is directed into the internal space of the box. In this model, it seems the air will pass over into the smaller inner box, possibly a component chamber or filter box. For the last part, we will talk about how the gas will get out from the box. First, intake fan. As we previously described, the fan on the left side pulls gas air into the box, creating positive pressure inside the enclosure. An exhaust outlet, the back of the box. The larger circular structure on the right wall, on the back of the wall, appears to be an exhaust port. With continuous inflow from the fan, pressure builds up slightly in the enclosure, naturally pushing gas out through this outlet.
What is calcium carbonate? Calcium carbonate is naturally occurring chemical compound consisting of the elements calcium, carbon and oxygen. It is a white, odorless and insoluble carbonate salt in water, but soluble in weak acids such as hydrochloric acid. Calcium carbonate is found widely in nature, for example, limestone, marble, chalk, seashell, coral, reefs, and snail. Next, we move to what is function of calcium carbonate to overcome air pollution. Calcium carbonate is used in industrial air pollution control system, primarily to filter or neutralize acid gases released from the combustion of fossil fuels such as coal, oil, and solid waste. Calcium carbonate also acts as naturally alkaline substance which reacts with acid gases to produce harmless compounds. For example, sulfur dioxide, nitrogen dioxide, and hydrogen chloride. Next, we look at chemical reaction process in CO2 buster. The chemical reaction process is acid gas neutralization. Calcium carbonate acts as a neutral alkaline substance which reacts with acid gases to produce harmless compound. For the example reactions, calcium carbonate combined with sulfur dioxide to become calcium sulfide and carbon dioxide. Harmful sulfur dioxide gas is converted to calcium sulfide, which is more stable and non-volatile.
In a world gasping under the weight of its own progress, we've reached a point where our cities are suffocating on their own emissions. From towering smokestacks to gridlocked streets, the problem is right in front of us, and it's growing. But there is hope. Introducing CO2 Buster, a revolutionary technology that doesn't just measure emissions, it captures and neutralizes the very carbon dioxide that's choking our planet. The question is, where do we place CO2 Buster for the maximum impact? Where can this innovation do the most good? First, let's look at urban areas, the beating heart of pollution. Our cities are home to millions of people and billions of emissions. Every day, cars, trucks, buses, and industrial plants pump out carbon. By installing CO2 buster on high-rise buildings and rooftops, we can filter carbon directly from the atmosphere, right where it's most needed. Finally, the conclusion. Let's talk about real pollution fighting powerhouse calcium carbonate or CaCO3. The simple compound plays a big role in controlling air pollution, especially in industries that release harmful gases like sulfur dioxide. So how does it work? It used in special system called CO2 buster, which help filter and neutralize acidic gases. That means fewer pollutants in the air, less acid rain, and reduce risk of respiratory health problems for people. But that's not all. Calcium carbonate is also environmentally friendly, cost effective, and easy to find, making it the perfect solution for the modern air filtration technology. So, this is all from us. Thank you.